A very good morning to one and all present here. Dear authors and invited guests, welcome to the technical session 4C. Myself Gargi Kalra, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2023, Jaipur, India. The 8th edition of this conference is being organized in a hybrid mode. Physical event was organized yesterday in Jaipur, India, and the virtual event is being held through Zoom today, yesterday, and today, that is 8th to 9th of December 2023. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the questions and answers. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks because we will need to take a snapshot at the end. If you have any query and update, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Dr. Ramesh Chandra Punia. He is a professor at the Department of Computer Science, Christ, deemed to be University, Bangalore, India. He completed his postdoctoral fellowship from the Cyber Physical Systems Laboratory, Department of ICT and Natural Sciences, Norwegian University of Science and Technology, Norway, and one more postdoctoral fellowship on the International Collaborative Project of a Prediction Model for Pandemic Disease using Machine Learning on Auckland University, USA, and Imam University, Saudi Arabia. His research interests include sustainable technologies, cyber physical systems, path planning, and collision avoidance in artificial intelligence and intelligent algorithms for autonomous systems. Sir, would you like to say a few words for the participants? Then you can open to do that.
Yes, Gargi, thank you for nice introductions. So I most welcome to all participants in ICTCS 2023. And hopefully we will learn a lot of things with the help of various participants. So all the best for this conference and your paper presentation. Yeah, please, over to you.
Thank you so much, sir. So let's move to the presentations. So the first paper we have is an efficient method for evaluating the two-terminal reliability with the parallel algorithm on the multi-core processor architecture. And this will be presented by Nguyen and Chuyen. You can share your screen and start the presentation.
Can you see my screen?
Yes.
Okay. I would like to present our research on an efficient method for evaluating the two-terminal reliability with a parallel algorithm on the multi-core processor architecture. Content of our study is the first is introduction of network reliability. The second propose our algorithm is called ENRE. And the third, we will implement an experiment of our proposed algorithm. The fourth, we will present the result of comparison with other algorithms. And finally, we give some conclusion and future work. About the introduction of network reliability, and we know that network reliability refers to ability of computer network to consistently and efficiently perform its intended function without interruption or failure. And reliability is applied in many fields, such as information system, manufacturing network, telecommunication network, and transportation system. Sorry, it's my and we can simulate the network in a combinatory graph with vertex and the edge. Like the slides, we have a graph with four nodes, and there's some edge, and we can group in three problem. First is two-terminal problem, A-terminal and O-terminal. In this study, we will solve the problem of the two-terminal. For example, we will find the minimal path from the source node to the destination node. After that, we will calculate the reliability of the path, and we propose a new algorithm based on the algorithm called SDP, and because SDP is the stand for sum of destroy products, is a wide use and easy implementation. Besides, some study implement this algorithm in sequential method, because of this implementation, it will affected by performance and accuracy risk in large network with many nodes or edge. So this paper we will propose a new improvement to calculate two-terminal reliability. We will utilize the FPC algorithm to transform the probability of the union into the sum of probabilities for individual events. Next, we will implement a parallel version. We take advantage of the power of the multi-core profession architecture in parallel computing. And finally, we will support to accelerate the execution time on large network with complex structure. This is a proposed algorithm that we have given. Its name PNRE. So first, I will introduce about FPC algorithm. This algorithm represents the operating probability of two nodes is a sum of individual event probabilities. And we assume that the state of the link between two nodes and alpha and beta. We have two states. The first is good when all the path is successful. We note is one, and the second status is bad when the path is not completed. We call when the value is zero. So the status of the whole system depend on the status of each element, each one, two, until each n. And we based on the reliability theory, we have a equation 1.6 like the slides. So we can calculate the probability of two nodes alpha to beta based on the summary of probability on each node. And when even for example P1, P2 are mutually exclusive, so the equation 1.6 can be represented as the equation in 1.8 and 1.9, because when we transfer to this equation, it's easier for implementation in programming. So from the equation 1.9, we will transform and apply the reliability the calculation. Here is the step of the proposed algorithm. You can see on the slide we have five steps. The first step we will calculate the matrix code name W. This is a matrix encompassing all minimal paths within the graph. For example, from the source node to destination node, there are many paths can reach from source to destination. So we will collect all the paths and find the minimal path possible from S to destination node. The next step, we will convert matrix W to into a vector to C. To C will contain common nodes which are included in path between node alpha and node beta. And in the third step, we will initialize data for a resource matrix we call R. And in step 4 until step 5, we will use some computation to calculate the reliability. For detail, I have it present in the paper for the step by step, and in the presentation we just usually the short of area. Next step, we paralyze in the LPC algorithm. We implement LPC algorithm into a parallel version. Much R will be generated from equation 1.x, and we partition each computing component of equation 1.5x into discrete parts. Each type when dedicated to processing is allocated for component autonomously. Listed from other as from this side, you can see that when we calculate K1, we will use
So, Ian, sorry to interrupt you, but your 8 minutes are almost over. So, I would like you to please conclude your presentation.
Sorry, can you see my screen?
Yes, we can see your screen, but your time is almost over. So, please conclude your presentation.
Sorry, I will hurry up.
Thank you.
Okay. So we will we have implement and experiment our program proposed algorithm on the system with configuration like you can see the slide. So, and we have implement on several network topology. We have totally 70 topology, and we will apply the same method to calculate our reliability on each topology. Series the topology we have 70, and here is the resource of implementation. So we can see that the reliability of we have calculated on each tuple, and we have made some comparison with the other algorithm. The first is simple algorithm for computing network reliability, and the second is the original LPC, and we can see the result on the table. Our proposed algorithm has improved in the time for calculating compared with other algorithm. So the result of comparison um, is improved from in tuple 6 with the 290 faster than SACNA algorithm. And from 2.7 to 2.9, we can improve the time for calculating, and especially in 2.9, our proposed algorithm has speed until 61,000 faster other algorithm. So in this study, we have proposed a new algorithm for calculating reliability of network based on original LPC algorithm. So for conclusion, um, we have proposed and implement algorithm to speed up as well as improve the time and utilize the parallel system in and employing parallel computing to speed up the reliability calculation. So that is all my study, and thank you for the listening. Sorry for if my presentation is over time. Thank you for listening.
Okay, Chian. Nice presentation. Can you let me what are the application of this proposed algorithm?
Yeah, this is our proposal algorithm.
Yeah, what are the applications where we can use and how it is perfectly working? Can you let me a little bit?
In this proposition, we will improve by use the parallel computing to separate calculate reliability of each single event. From the step 4 and the step 5, we will calculate and return the R matrix.
No, Chan, my question is that what is the applications of this PNRE algorithm that you have proposed?
We propose algorithm tools utilize the parallel computing in calculating the reliability of a network topology.
Which type of the topology?
Uh,
Which type of the topology where we can use?
this is applied for the specific topology. But as you can see, we have implemented in a particular network topology. Yes.
Okay.
And for each.
Thank you. Thank you. Thank you so much. Have a nice day.
Okay. Any question for me, please?
Yes, yes.
Anyone else having any questions?
Go ahead, ma'am.
Thank you for your presentation. So let's move to the next presentation. So the next paper we have is attendance system using face detection and face recognition. And this will be presented by Jamin N. Undavia. Are you there?
Actually, Jaimin is a little bit occupied, so I would be presenting. I am Harsh Chavda.
Okay, no issue. You can share your screen and start the presentation.
Sure. Good morning, everyone. My paper ID is 386, and I would be presenting on attendance system using face detection and face recognition. So, talking about the introduction, the face recognition is used since long, and we have been using it in our mobile phones and in our regular processes also. But to enhance it, like to make other systems, for example this attendance system and the few of the other systems for logging into the to a organization. We have introduced a new software which is called attendance system using face recognition. So this software contains face detection, feature extraction, and face recognition steps, which which we have integrated, and we have combined it and made a model which recognizes and marks the attendance of a particular user, which whenever he pops up to the camera, his attendance is marked. Whenever he blinks his eyes, his attendance will be marked. So this is the short introduction on it. Making it to a detailed form. What is face detection? So face detection is something which is used in a live video capture mode. Like whenever we start the software, start this model for regular attendance system. So it starts the camera, and then it detects the face, that where is this face located, at which coordinates and which locations is this face located. So the detection phase is being carried out by this face detection, and we have used the algorithm of eigen faces with PCA. So this eigen faces algorithm is a much efficient algorithm, and it identifies, or it locates the person in a correct form. So for that we have used this face detection. And then there is feature extraction. So for feature extraction, um, for extracting all the features, we have used PCA algorithm, which extracts the necessary features like the coordinates, the vectors that we transform the image to. That all those things are being done by this PCA algorithm, which carries out the feature extraction process. Then there is recognition of the face that is identified. So for recognition, the eigenfaces algorithm compares this algorithm compares the images of a data set to a live image that is being popped up towards the camera. So once the coordinates and the vectors matches for a particular image, it marks the attendance whenever a user blinks his eyes. So yes, and talking about the advantages and disadvantages. So advantages are, as we know that.
Sorry to interruption. What are the methodology you have used? Try to focus on that part on.
Okay, so talking about the methodology, we have used eigenfaces algorithm and PCA. So uh, if we combine both the things, it makes the face detection as well as face recognition process easier and more efficient. Like we will be facing many issues like the brightness issue, the uh, other issues like the similarity of coordinate of faces, and that all issues are being resolved by this eigenfaces with PCA algorithm. So this is a flowchart that we have used. Um, so whenever a user starts, like whenever a user logs into to our system, it takes all the necessary inputs, and then it also asks for for a image. The image that a user inputs over the system is being processed using this eigenfaces algorithm. And while processing all the coordinates and all the features that the I the values of a particular eye and the coordinates of it are being processed and been saved in the database, and wherein once that particular user pops up, his face will be identified, recognized, and the attendance will be marked. So can I demonstrate my system?
Okay. First, you let me what the outcome of that.
Sorry,
First, you let me what is the outcome of this.
outcome. Outcome means you mean what? Wherein we can use this system.
No. Outcome means what the result you got actually. You are detecting the face or not. If detecting, then what the accuracy and efficiency you got it.
Okay, so talking about the accuracy of this face detection and recognition model. So accuracy is about 83 percentage, and which has now increased up to 91%, 91.52 percentage. And this is a data that this has identified. So it identifies the data based on the this model, like whenever we pops up towards the camera, it gives the name or the ID of that particular student or the employee. If you can see this screen, this image that I have selected, so it detects and recognizes this face, and it pops up the name over there. That is it. If this is a correct name, you need to blink your eye in order to save the attendance. So this was the student of this was a student, and his ID was correct, so he just blinked his eyes and his attendance was marked over here. And the accuracy for this model is has increased to 91.52 percentage. So we have used the bulk of images for training and to store the coordinates of all the students that we have in our college.
Okay, what is the size of your data set?
So now it is about 600 images that we have.
600 images only. Okay, so a lot of work has been done regarding the recognitions, different type of the recognitions that you have applied the CNN, DNN, and different type of the learnings. So, what you have applied and what is the novelty in your research?
So, talking about the application part that we have done, so eigenfaces, we all know that eigenfaces is a very known technique, but if we integrate it with PCA algorithm, it enhances the coordinates that are matched. It enhances the accuracy. So while we make this model of attendance, so we have only used the eigenfaces, but then to increase the accuracy we use the PCA also. So that made the accuracy of this model more better. So if we know that in major of our phones we have this unlock by face ID, but it is not efficient in whenever we are in sunlight or whenever we are in a dark. So we have integrated a brightness auto brightness enhancement in this system. So it checks the brightness, like if we are in a sunlight, then it shatters down some of the brightness and makes the face visible. If we are in a dark, it glows, like the screen glows, and the face is identified and recognized. So that enhancement we have done in
Okay,
our system.
it's okay, but my suggestion is that a lot of work has been done. So, in coming futures, work try to compare the things and how it is different from the other. So, researchers can read the clearly. Okay, so this is my suggestions. Yeah, over to you, madam. And if any questions from audience science, so welcome.
Anyone having any questions? Okay. Thank you for your presentation.
Thank you.
Let's move to the next one. And the next paper is Bias Resilient Elephant Flow Detection in Distributed SDNs through Federated Learning. And this will be presented by Kauter Bausaud. Are you there? Okay.
She's not here.
Okay. So let's move to the next one. And the next paper is dark channel prior base single image dehazing using type 2 fuzzy sets for edge enhancement in dehazed images. And this will be presented by Geeta. You can share your screen and start the presentation.
Hello, good morning, sir. Good morning, ma'am. Now, can you hear my voice?
Yes, we can hear you.
Thank you. I am sharing my screen, ma'am.
Okay.
Hello, ma'am. Can you visible my screen?
Yes, your screen is visible.
Okay. Good morning to all. Myself, Geeta, presenting a dark channel prior based single image dehazing using type 2 fuzzy sets for edge enhancement in dehazed images. So as we know, dehazing refers to methods dehazed for haze removal from the images to increase the visibility of objects in the image. In this paper, I have approached a DCP approach to remove haze from images is employed. The quality of the haze removed images is increased by sharpening the edges of the objects in the image by using type 2 fuzzy sets. So the images are taken from the Kaggle dataset for the experiments, and I have calculated the PSNR and structural similarity index to test the effectiveness of proposed method. So as we all know, haze or fog in images degrades its quality and reduces its visibility. So it is because due to several problems like dust, water droplets, or pollution. These degrades the quality of images, and the image get hazy as shown in this two examples, where we have haze or foggy images in which the light is bright, but the particles or objects cannot clearly visible. To overcome these, we have to apply some dehazing techniques. That is, we applied here dark channel prior method to become a dehaze image as seen from this example where the objects are clear. So the dark channel prior in most outdoor images even in hazy condition, there are some local areas known as dark channel where the intensity is very low. So, to follow this dark channel, we have to apply some steps which consist dark channel, in which the minimum value of color channel RGB at each pixel in a local patch of the image. Second step is atmospheric light estimation. Estimates the global atmospheric light with which is a color of the sunlight affected by the haze. Transmission map. The transmission map decreases the portion of light that travels from the scene to the camera, accounting for the haze. Next one is haze removal. After calculating the transmission map, it can be used to recover the haze-free image. After this, we are having fine-tuning where we have to enhance the image, edges of the image. Here, we are applying type 2 fuzzy sets. So, the proposed methodology is, first, we are having the inputs of video frames or images in sequence. First, dark channel estimated. The next is atmospheric estimation, then transmission map, then scene radiance and recognition. Lastly, we have the images where we have to enhance that image by using type 2 fuzzy set. The fuzzies, as we know, there are two fuzzy type 1 and type 2 fuzzy sets. I am using here type 2 fuzzy set. where we are having the first primary membership function and the second one secondary membership function, which enhance the edges of the image. So for that, I use the iHaze images. iHaze are indoor images which having various sources of pollutants, dust, and other airborne particles. And the iHaze data set contains 25 indoor hazy images of size 2833 into 4657 pixel for a training. It has 5 hazy images for validation along with their corresponding ground images. Next, I use the OHAZE dataset, which are the outdoor images in hazy or foggy conditions. The factors which affect these images are air pollution, humidity, and other atmospheric conditions. The OHAZE dataset contains 35 hazy images. Size is 2833 into 4657 pixel for training. It has 5 hazy images for validation along with their corresponding ground truth images. So I have these experimental results where this is the original image. Next, I use the type 2 fuzzy set to enhance the edges of the image in dark channel prior images. And next, lastly, we got the output result in which we have the dehazed image after applying the type proposed method or type 2 fuzzy set method. So I calculate the parameters like PSNR by using this equation and SSIM by using this equation, then LOV by using this equation. Next is NIQV by using this equation. So I lastly have these results where to my these images. So for these images, first I apply the KE methods, and I have got the execution time 9.5 and PSNR 13.8 and SSIM 0.5. And again, I apply for image 2, 3, and 4. Then I apply for these images K-chain method, and I got the execution time like 9.8, 14.1, and SSIM is 0.5. For those images, I applied my DCP method, where in which I have the execution time 7.2 and PSNR 16.9 and SSIM is 0.9. So comparing these two methods, my PSNR is a little better. My PSNR is better. So similarly, I go through, I calculate the NIQ and LOV, but comparing these PSNR and SSIM, so for my method, it is a good one. So I calculate by using this graph where the green signal is my DCP applied method, then a red one is K-chain, and blue one is he et al. So these are the PSNR values where my method having good values compared to these two methods. So the conclusion of mine is the proposed algorithm yields better result with DCP for haze removal system that has lowest execution time compared to with the other method. The results obtained using fuzzy edge detection technique are better in terms of image quality. The effectiveness of method is described in terms of quantitative parameters, namely PSNR, more haze removal methods to perform better results, like CNN, in which I have to auto a drive. Then in CNN techniques, I want to use for next. Okay.
Okay, Geeta,
Sir.
that your proposed algorithms you have applied with the single image, I hope, as per your title, and you have shared the different experimental results also. So
Sir.
suppose, for example, we will apply on the two or more than two images and with your proposed algorithms. So you have gone through this?
There we have more frames and images. Frames. So to calculate them, I have to keep my laptop on only. And watching those results is little difficult.
Okay.
So I have to keep it on only. All the PSNRIs are inbuilt functions and they give the results inbuilt. So therefore, I have that problem in that one.
Okay. Okay. Okay, thank you. Maybe in the future work with the GPU, you can apply the more than two images and you can get the results. I hope.
No, sir, I have applied for more. Here only I am showing only few, that is 4 and 5, but I have applied for more than 25, sir.
But
then
in your title, you have given down the single image. So why?
Sir,
It's a
because
contradiction.
I'm using the keychain paper who worked on the single image. Single image haze removal using dark channel care. So I'm following his papers.
That means results. Your results are with multiple images.
Compared with keychain.
No, your results are with multiple images or single images result.
No, sir. I have multiple images. I have.
So I hope you need to think about that your title also, because your title is showing on the single image. So based on this, you need to update or you can.
Okay, sir. And next, further, I want to continue on CNN, sir. Convolution neural method.
Yeah. Okay. Thank you. Yeah. Over to you, madam.
Thank you for your presentation.
Okay. Thank you, ma'am.
Let's move to the next presentation. And the next paper we have is Industrial Worker Safety Device with Proactive Gas Leak and Fire Protection System. And this will be presented by VSN Lokesh Yaramallu. You can share your screen and start the presentation.
Good morning, ma'am. Am I audible?
Good morning. Yes, you're audible.
Yeah. Is my screen being presented?
Yes, it's visible.
Good morning, people. This is Lokesh Harmalu. I'm a first year student in artificial intelligence and computer science in Amrita Vishwavidyapitham, Amritsar. The work we are going to propose today is it's a small device, industrial worker safety device with, basically an extension of the devices which are right now. Actually, we have many statistics and data regarding how accidents being happened there in the industrial and manufacturing sector. So whatever the case, maybe the accidents are decreasing due to the increasing technology, but this is a small contribution and then like an addition to the present devices. We can see many gas leakages or whatever fire accidents. Our device try to prevent them. Just try to alert people and decrease the damage. Okay. This is a problem statement. I just represented the data. Even though the yearly the accident rate is even reducing, we just added few things to the present applications. That's it, to reduce the risks and to aware people regarding the accidents happening around them. The SDGs comes under our project SDG 3, good health and well-being, industrial innovation and infrastructure, sustainable cities and communities. How this can be applied to our prototype, I'll be further proceed. Few of our references we took under when we are doing our project. Coming to the methodology, we have integrated two gas detection sensors, MQ5 and MQ135, a flame detection sensor, and a temperature humidity detection sensor. So what we did is we just made a level order system so that at particular levels the warning levels will be different. The warnings can be adjusted so that certain needy people they can receive the warning messages when the MQ5 or MQ135, whatever the sensor. As of now, this is a prototype, so we just made a prototype thing. The gas detection sensors, as they reach their first threshold level upon detecting the leakage gas, automatically upon that warning system will be given messages to the required people. And if the if the the ppm of the gas goes next threshold level or the maximum level, we also integrated the servo motor thing which disables the valve. I mean, there must be a source, right, for the gas that is being operated inside the industry. The main source of the valve, the main valve of the gas source will be turned off upon this thing. And even when a flame is detected, the work done by the system is same. Or even, in a few cases there may be flame detection rate that may not be so accurate. Temperature and humidity sensors are also integrated with the present sensors. That's the working and methodology of the device. Yeah, the messages will. One more thing is the messages will be sent to the required. The registered people through Wi-Fi module. A Wi-Fi module is integrated. Arduino is used for assembling these devices, small chips. You can see the program logic. As I mentioned earlier, the device capture the values. If the values are, the values means the temperature or whatever the flame sensor flame thing, and the gas ppm levels. If they are normal, it goes on detection. The first threshold, it will give the warning level, and the final threshold, it all get closed. And again, this loop continues as long as it's working. And this is a proposed model. You can see the diagram of and these are the components. And later, you can see this has been captured in the Arduino IDE when we are doing our experiment. You can see the things. This is our final prototype. We just did make it, which it was made for the presentation. We can see exhaust fan. When there is a gas leakage, automatically the exhaust fan enables. The same time, servo motor. We can see the servo motor for the disabling the valve. Wi-Fi module for sending messages, indicators. Buzzers and lights, buzzers and lights. This is an IR flame sensor and a IR flame sensor for the flame detection, a DHT11 sensor for the temperature humidity, a gas sensor for ppm, gas ppm level. You can see the Wi-Fi module send messages to to the mobile through WhatsApp bot or Telegram bot can be integrated with the Wi-Fi module so that it can send the messages. What I can conclude is, many devices and many software, much technology has been developed under this thing. But what we did is we just integrated few things. We can see both the gas sensor and fire reduction sensor both has been integrated as along with a safety valve is being integrated so that it both prevention and alarming both are being done here. A small addition from our side to the current devices. This is I can conclude this project like this.
Okay.
Yeah.
Okay,
You
Lokesh.
have any questions, sir?
Yeah, Lokesh, good job. as a BTech students actually. So first thing is you need to check the novelty, as you already told you some little bit things we have included, but I hope such type of the device is available or not. You need to check it. But my concern is that suppose your module is connected with Wi-Fi and Wi-Fi is not working, then how it will work with the for the alarm actually. So that's I'm afraid about that.
Yeah, sir. Actually, I would like to openly say that we also use a GSM SIM module, sir. GSM. As this is a prototype, we thought of. I mean, we just tried with both GSM SIM module and ESP sensor. Uh, right now, it compared to I mean SIM module, this worked good. The thing is, see, this is mainly been integrated in the industrial area sector, right? I think that I mean that the chances for malfunctioning is too low, and that's what we discussed in the conclusion. Time to time, we had checked for the malfunction, and further in the further updates also, we have to try decrease the rate of malfunctioning of the device in any case, even while sending a message through this Wi-Fi module. Or we can replace this Wi-Fi module by through a GSM SIM module, whatever.
It will be better actually because this is the safety device. Suppose at that time Wi-Fi is not working, then how to safely do the things actually, or the alarm the to the concerned people. So I hope you can think in this way also in the future work.
Yes, sir,
Okay,
of course.
good. All the best.
Thank you, sir.
Thank you. Go ahead, Gargi.
Thank you for your presentation.
Thank you, ma'am.
Let's move to the next paper. So the next paper we have is IoT-enabled solar-powered water trash collector with conveyor belt, and this will be presented by Devpriya S. You can share your screen and start the presentation.
Ma'am, am I audible?
Yes, you are audible.
So, good morning to all. My name is Devpriya. I'm a BTech student, first year BTech student. So, my topic is IoT enabled solar power water trash collector with conveyor belt. Like we all know that for the larger water bodies like oceans and sea, we can use ships and all for the bulk collection of trashes. But for some water bodies like smaller water bodies like backwaters, small lakes, we are not able to collect water bodies like trashes from that using the ships and all. So this project is mainly based for collecting the trashes like floating wastes and plastic from the smaller water bodies like backwaters and small lakes. So so the main issue is that the water pollution is increasing day by day. So uh, it is according to WHO, the 2 million people are uh, needed to drink polluted water because there is deficiency of fresh water. So the main source of fresh waters are like our nearby lakes and backwaters, and we can't depend on sea and oceans. So like fresh water, it is much important for us for the safety environment also, and we are using solar power, and we are also using a supporting battery also for like there is sometimes we need to initialize the energy, and also there is something like there is also maybe sometimes solar power is not much efficient for that, so we are using batteries also, and mainly we are depending on solar power, which is a renewable energy, and it is totally eco-friendly also. So, in ships and all, it is getting polluted to the water sometimes also because of the fuel used in that. So, it is completely eco-friendly, and the SDGs address are 7, 11, and 12, which is affordable and clean energy, sustainable cities and communities, and responsible consumption and production. The main objectives are uh, uh, we will need to make the society aware about the importance of the fresh waters, and making awareness about the citizens, And the floating debris and this plastic waste, which also causes the decrease in the oxygen consumption of the water bodies and the aqua systems. Uh, this is the what we have implemented. So as we can see, this is the used batteries, and this is a solar power. That solar panel is connected in the backside of this, and this is a conveyor belt. We were not able to implement through original best, as there is no it is not getting from market. So this is the basic structure of that. So we are the what are the new things we have implemented is like we have in the actual system, the existing one, it is used as a single bucket which will collect the waste automatically. We are using Bluetooth control to travel through the water. And but here we are implementing a conveyor belt which will more efficient than a bucket kept in the front of that device. And we are using L293D motors, which is not mentioned in the original one. And this is more efficient than the original or already existing one. And solar power, which is also renewable energy, it's self-sufficient, and we don't want to charge by every time. Like the most is like we don't have that much time for going behind this and like charging and all. So we are using solar power, which is also available in plenty, so that we don't want to make that much care about that. This is what the working of it, and we are using the Bluetooth module. This is connected to the Arduino, which is we have functioned it, and these two motors are connected to the conveyor belt, and two motors are connected to the backside. This is two motors will help us to move, and this motor will make the conveyor belt move, so that the conveyor belt motors will be always be rotating to front, which will collect the waste, and this propellers this motors are controlled by Bluetooth, and we can change the direction according to that. Uh, and the power which is also connected to solar, like that we can charge it towards it. This is a working flowchart of that. Like uh, and we have successfully implemented it, and we have one of the demo also. After that, we were able to collect trashes, but the thing is that we were not able to implement the perfect belt for that one, which is not available for us. But we have a simple demo with the like plastic covering conveyor belt, and we were able to implement that. And we were able to like we can collect the trashes using the conveyor belt, and we can collect in a tray which is kept behind the conveyor belt, so that after that we can move the device to our shop, so that we can collect the waste from that basket. And these are the results, like this show the moment which will we can which we have done in that using Bluetooth, and this is the app which we use to implement the moments also. In conclusion, like it is much efficient, and by using the solar power and using the conveyor belt, and it will also remove like floating wastes and plastic waste from the top of that, so such that the aquatic environment also improves, and the health, the drinking and freshwater rate also increases. So the references we have referred to. Thank you, ma'am. Any questions?
Yeah. Good job. Actually, theoretically, we understood the things, but at the real time, you have implemented these things, and what the accuracy and how it is working, and it's working perfectly or not?
Yeah, it was partially working because the conveyor belt which we have implemented was using the clothes and plastics. So we were not able to get the original conveyor belt which should be used from the market. Whatever is getting is we have ordered the conveyor belt, but it is getting from a rubber sheet, so it's not applicable for that. So we have used it, it has implemented almost in 90%. That's it.
Okay, so what the detection system? This is the garbage or this is not garbage or the waste of water or not? How you identify the things?
Yeah, we can control it by Bluetooth device. It is not detecting each one. We have to manually control the device and implementing by moving forward, backward, side, right. Like that, we can use it from the shore itself. So that we are planning for implementing it as an autonomous system in the future works.
Okay. Okay. Thank you. Thank you for
Thank
nice
you, sir.
presentation. Yeah.
Thank you.
Over to you, madam.
Thank you for your presentation.
Thank you, ma'am.
Let's move to the next one. So the next presentation we have is music recommendation systems, techniques, use cases, and challenges. And this will be presented by Shakti Kumar V. Patel. You can share your screen and start the presentation.
Thank you, ma'am. Am I audible properly?
Yes, you're audible.
Okay, fine. I shared my screen. I hope it is visible. So, shall I start, ma'am?
Yes, you can start.
All right. So, good morning to everyone. Myself, Shakti Patel, and my paper presentation title is Visual Recognition System Techniques and Use Case and Challenges that we are going to discuss. And my paper ID is 336. This is the outline of my presentation. We'll start with introduction, and then we'll discuss methods which are involved in music recognition systems. These are the two core methods which we are going to discuss: content-based filtering, collaborative filtering, challenges, and future scope. And then at the end, we will have conclusion of it. So, as we begin with the introduction, music recognition systems, as we all are aware, and the majority of giant applications like Ghana.com, Apple Music, Spotify, they all are utilizing music recognition system to their users. So, a music recognition system is a system that suggests the music to the users based on their preferences and listening habits and other features as well. Now, why music recognition systems are important? Why, in fact, recognition systems, we have plenty of recognition systems. Like we can have article recognition systems, news recognition systems, right? But music recognition system makes it special because of its personalizations, then discovery of music, and then engagement of users. So it has got plenty of varieties over here. So these are the important things with respect to music recognition system. Then particularities of music recognition systems, what features that should be focused while considering music recognition systems. So these are the identified particularities. First one is personalizations. User preferences will always be there when they are customizing their music playlist. So they will have different habits according to the different time of the day. So that's the first thing, personalization. Next one is context. Music recommendation systems also needs to consider the context of the recommendation systems. Like in certain contexts, we can consider the time of the day, the mood, activity, the period, and the listening history. There are things we can consider here. Diversity, when we recommend music to a particular user at that time, if your system behaves to recommend similar kind of items, so in that case user will always be recommended a particular stream of musics only, a type of music. But diversity is also there, that user tends to be diverse according to different times. Sometimes they need a music of tempo, sometimes they need mild music or likewise. So diversity plays an important role in music recognition system. Exploration, As a recommendation system, user also encourages to explore new music, new taste, new preferences, and they
Quickly,
need to.
sorry to interrupt you. Come to the methodology, what you did. So you focus on the methodology and research results that is
Right.
required.
As a review paper, I focused on methodologies like collaborative filtering, content-based filtering, and hybrid approaches. So, collaborative filtering is a kind of methodology where user will be recommended with a similar user taste. Like user A has listened music A and B. So, if a user B, which is having similar preferences with similar user A, then user B is also going to recommend music A and B. That is likelihood, we can say. And to implement collaborative filtering, these two are the core methods which are being utilized: matrix factorization and network-based methods, where we are finding cosine similarities and other things. And based on that, we are judging that which two users are more relevant, right? In fact, in collaborative filtering, we may go with user similarity wise as well as item similarity wise as well. And next one is content based filtering. Here the focus will be on musics, that which musics are likely together. So uh, in that case we are considering metadata of that music, the audio features of that music, right? So all the songs which belongs to a particular mood or particular genre will be likelihood. So if user A listens a particular song, so with content based filtering it is also going to refer you the similar kind of music. But there are a few disadvantages of these things as well. New user or new item, new music track is never going to recommend because it is we can say in that case it might not be considered while recommending. The final one is hybrid approach. In hybrid approach, there are certain researchers which are combining these two approaches, like collaborative filtering and controlled filtering. They are applying both these algorithms and they are generating a corresponding set of results. And over that set of results, they are assigning different weights, and according to that weights, they are combining these two approaches. And finally, they are generating particular recognition systems. So that seems to be a better while rather than considering a particular one like collaborative filtering or content-based filtering. So again, in that case, we may have matrix factorizations with content features and ensemble methods. Uh, One more approach is that is called two-stage recommendation systems. We are also calling that as a multi-model system. So in that case, in first stage, we are generating a bunch of records or bunch of tracks from the data set. And in a later stage, we are refining that thing using ranking algorithms or something like that, right? So these are the three baseline methods which are generally utilized. This is the figure of collaborative filtering and content-based filtering, how exactly they are working, which I discussed earlier. That in collaborative filtering, you may either go with similar users kind of pattern, and according to that, the next track will be recommended. In content-based filtering, it will refer to the item metadata and item preferences to find the similar kind of songs. And if user listens a particular song, then the next song will be a similar kind of things. So these are the baseline methods we have. And the challenges associated with this particular system. So there are plenty of challenges associated with music recognition systems. So which I mentioned here. That is, one thing is data sparsity. We don't have enough data to accurately predict the preferences. So in that case, users have listened. We have history over there, but users never tends to generate a feedback like how much feedback should be given to music listen. So in that case, if we'll consider the music feedback data, so in that case, data would be very sparse in that case. Next problem is cold start problem. This is the major issue which a majority of MRS systems are facing. Recommending for new users or items. So when a new user arrives or when a new track is arrives, where to recommend that things, because that user or that track doesn't have any kind of history. So in that case, that system majority of systems fails in that case. So they need to follow different approach apart from the regular algorithms. Next challenge is novelty and serendipity. Here we need to balance that how familiar and new music should be recommended to a particular user. And user might like it, might not be like it. So we need to crack that thing. explainability. User must be aware that on what basis that particular music is being recommended. So this is also kind of challenge which is being right now have in music recommendation systems. The next thing is scalability. Your system as a recommendation system, you must be able to manage large volumes of data and large number of users. So you might have designed initially algorithms for millions of users and millions of tracks, right? So but this data set is going to enhance day by day, and your users are also going to enhance day by day. So a recommendation system should be flexible, should be scalable. It should be able to manage large volumes of data and users.
Okay, Sakti.
Right.
Actually, yeah. So you that means you got the with the help of the music recommendation system, a lot of things has been done. So you are working with some offline or online. Like for example, I want to listen a song on the Spotify. So in that case,
No, it will be an offline algorithm kind of things. And sir, this paper is just a review paper. So I just
yeah,
reviewed all these methodologies and challenges associated with the music recognition system.
I got your point. This is the only the review paper. So it's offline based or online based.
It's offline based.
So what the use of for the readers actually? What message you want to give to the readers so that based on this your paper they proceed the
Uh, uh,
research. That's the
if we, as a researcher, if we are going to design a system for to recommend music, so in that case, what are the challenges associated with that thing, and what are the methodologies available, and
no.
how
The
you can
concern is
utilize.
that especially offline. Suppose the same thing you will did for the online, then that's good for researchers. They can get the message
Okay,
and based
fine.
on this they can start. So no,
Okay.
actually, my concern is I'm wondering about that offline. You did the things all for the offline, and I hope this is out of
Actually, that offline version could be come up with online as well. We can club it with a real-time data set as well.
how it is. Can you little bit tell how you got the review these things?
Uh, See, the primary focus is of candidate generation in that case. So in that case, we may utilize existing data set.
No,
Uh,
as per my mood, you will recommend the particular music. Suppose I'm happy or I'm sad, so accordingly I will choose the particular type of the music. So how to do
so
or
in
plan?
that case, we need to utilize metadata of my each track. So there will be for certain tracks which are associated according to moods.
So in the
So
offline, how what the use actually? I'm wondering about that. Offline, it's okay. I can give my like some emoji or something like that. I'm happy or I'm sad. So in that,
In that case, sir, we may consider your listening history and your time of the day when you are when you are referring what kind of music. So according to that, on next station, that system might suggest you according to that.
okay, but I hope you need to think in this way, and
Yeah,
I
yeah,
hope
yeah.
you
Sure,
will
sir.
get.
I got your point.
Okay, okay. Thank you. Thank
Okay,
you. All
sir.
the best. Over to you, madam.
Thank you for your presentation.
Thank you so much, ma'am.
Let's move to the next one. So the next paper we have is Transfer Learning Techniques in Medical Image Classification. And this will be presented by Radhika Shetty. You can share your screen and start the presentation.
Hello, am I audible, ma'am?
Yes, you're audible.
Is my PPT is visible, ma'am?
Yes, it's visible.
Um, Good morning, everyone. I'm Radhika Shetty. I'm a research scholar under the VTU Belgavi, Karnataka. I'm going to present my survey paper on transfer learning techniques in medical image classification. Medical imaging is crucial for diagnosis, treatment planning, and patient care. Deep learning, particularly convolution neural networks, have shown remarkable success in image analysis tasks. But these deep learning models require large amount of labeled data, which is difficult to get in medical domain due to the privacy concerns, data acquisition tools, and need for expert annotation. So here, transfer learning acts as a bridge to overcome this data scarcity gap by transferring the knowledge from pre-trained model into medical imaging task. So here, instead of training the model from scratch, transfer learning starts with a pre-trained model and fine-tune it on the similar medical data set. This will give better performance even with the limited labeled medical data. So under transfer learning, there are different techniques which can be applicable for medical images. I'm going to discuss few of them. The first one is feature extraction and fine tuning. So here, this will involve using a pre-trained model to extract the generic features from the images. These captured features are in the form of an hierarchical representation of the input data. Once if the model is pre-trained, then it is adapted to the medical image domain by fine-tuning its parameter on the smaller domain-specific data set. So it is effective for a larger data set, improved model adaptability. The next one is domain adaptation. This aim to bridge the gap between source domain and the target domain. Source domain is the one where a model is pre-trained, and the target one is the set of medical image what we will consider. So it basically addresses the differences in the distribution and the characteristics in the two domains what we will consider. Here some techniques like as adversarial training or aligning the future distribution of the source and the target domain can be used. So this will be helpful to generalize the medical domain. The next one is multitask learning. Here, a model is trying to perform multiple related tasks simultaneously. So, in terms of medical images, it may be classifying the different diseases or it may be predicting different clinical outcomes. So here, learning from a multiple task will help the model to capture different features and a relationship within the data, and it will also improve the generalization. The next model is self-supervised learning. So here, this basically involves training the model without explicit labels. Instead, it will be rely on the generated pseudo labels. So in medical imaging, this can be used to identify missing part of the images or image rotation or any other self-generated task to to learn the representation without relying on the external annotation. Based upon these studies, I have done my literature survey on a different set of papers, and I have identified few key points out of this. The first one is effective use of pre-trained models in medical image classification. So here, pre-trained models like ImageNet are very popular in the case of computer vision. So basically here the pre-trained models are used to extract the features and represent it in an hierarchical manner. After that, transfer learning is used to fine-tune the models on the medical data set to improve the performance in tasks such as disease classification or organ segmentation. The domain adaptation method addressing domain shift challenges. Domain shift will,
Madam, come
yeah.
focus on your methodology, what you did and what you applied, so you can understand
Uh, so,
what
so
results are
actually,
coming.
this is a survey paper which basically discuss about the different transfer learning techniques because I'm doing my research on transfer learning. So this is a study of different methods that are present in medical imaging.
So in this area, a lot of work has been done. So what the review and what the outcomes as per your research paper?
According to me, using transfer learning along with deep learning, it will improve the accuracy of the model. And if you consider any
No,
medical,
your paper is the review based, na, survey based.
it is a survey, sir, actually.
Yeah, what the survey outcome actually? So a lot of
It is a study
in a
of
medical
yeah,
line.
study of different.
Yes, madam. Yes, madam.
Yeah. So based upon, shall I continue, sir?
Yes, yes, yes.
Yes. Uh, So basically here this survey basically demonstrate the impact of a transfer landing on cancer detection and
No,
disease
what
automation.
demonstrate you?
Uh,
Can I see what the demonstration?
uh, Demonstration in the sense actually I have used this transfer learning method on ImageNet to
Which
identify.
method is better according to your literature survey?
Actually, time being, I'm method depends upon what kind of application we are using. Usually, in the transfer learning, we will get pre-trained models, and later we are going to use that model, and we are going to just fine tune that model based upon the medical images what we have. Whenever the data set is very less.
Okay, you written in your this slide highlighted the literature survey on based on the cancer detection.
Yes,
So
sir. Because I'm
which
doing my research on cancer detection.
which papers you highlighted and they worked well in this area?
Uh, there are various set of papers, sir. I have not specified a particular paper due to the time limitation. So I
Okay,
have just
my expectation is that suppose as a reader we are expecting you have give some tabular form or something. So the literature, so that based on this literature review, the coming researchers can study and they can proceed for the more research gap in this area.
yes, sir. I have just taken the few points what I have learned because of this literature survey.
Okay, okay. I hope you need to include in coming the future work. And
Okay, sir.
okay, thank you. Okay, yes, over to you, ma'am. Thank you.
Thank you, sir.
Thank you for your presentation. Let's move to the next paper. So the next paper we have is Unraveling Obfuscated Malware Through Memory Feature Engineering and Ensemble Learning. And this will be presented by Yogesh. You can share your screen and start the presentation.
Yeah, ma'am. Very good morning, ma'am.
Good morning.
Hello, ma'am. Yeah. Hello, ma'am. Very good morning, ma'am.
Good morning.
Yeah, ma'am. Actually, see, ma'am. Today the presenter author is not there, ma'am. Actually, have some problem, so we went out. So actually, I am one of the author in this paper. Can you present now?
Yes, you can present
Just
of the
just
author.
let me know the name first.
Okay, sir. Very good morning to all of you. So today we're going to present handling obfuscate malware through memory features engineering and ensemble learning. This is a paper title. So So this is the agenda of today presentation. So introduction about the papers and what are the work related work, existing work we consider in this paper and proposed methodology. So and finally explain the result and discussions and conclusion, and I have some reference. So malware, which is a short and for Apple software, was initially developed for personal computers in the year of 1980 and propagated via floppy. So traditional methods frequently rely on signature-based detections, which involves comparing unclassified software to previously discovered malicious software. So the aim of this studies is to examine and analyze the classification performance of two different machine learning techniques for malware detection. The basic of this paper, actually in this paper they have used CICS small memory MEM 2002-20. This is the name of the data sets. So this data is completely malware related data sets. So basically we all of you know that there are several malware categories such as like worm virus, bot and botnet, Trojan horse. So using this data set, so based on some machine model, we can identify that malware detection. So this is a related work, some existing work in this paper. I consider some most related existing works related to this work. So this is the aim of in this paper, using some machine learning models, using some advanced machine learning techniques, and based on some feature engineering concept. just we can identify the detect and classify the types of malware present in systems. So this is a overview of this paper. So this is a description about the data set. So this is a publicly available data set. See, this data set contains some different kinds of malware. Just you have to see here. I have to show some graphical representation. So the data set consists of 52 columns and 58,597 rows. So this is a proposed methodology. Usually, so based on this data, we can prepare one basic machine learning model. See, basically, first we'll take a raw data set in this, the malware data set. After that, we'll do from pre-process because whenever we're working with any machine learning models, any deep learning model, the pre-process method is very important. So after that, we apply some feature engineering concept. So and finally, after the feature engineering, we can using some advanced machine learning models, we classified it. So finally, we are getting some results. So these are experimental results. So out of these results, I got 89.2% accuracy in decision classifiers. So I got more accuracy in nearest centroid model. So it's nearly got 91% 29 accuracy. So on precision also it got almost more than 90% of precision values. Hello, ma'am. So hello.
Yes.
Yeah. So this is our final. So results. So the graphical representations of how your model is getting how much accuracy is. So based on that, so malware data sets. So this is some conclusions. So in this research, the model was specifically designed to utilize the memory feature engineering conjunctions with a stack sensible learner to achieve this research work. So to find the optimal combination of base learner and meta learners, various configurations were explored using the custom datasets. So ultimately, decision tree random forest, the grid search about almost effective Bayesian learners will. So I can apply all these different kinds of machine learning algorithms.
Yeah, okay. You applied the whole algorithms in your research. So what the novelty actually?
Actually, to be frank, in this there is no nothing much of novelty. So just we'll take that malware data set. So based on the data set, how the malware is detected on the systems. So just using some machine learning model, just have to detect that malware functionalities, how it is affected to systems. So there is no, to be frank, there is no novelty in this papers actually. I have to do
what
some.
type? What size? What the data size?
So so the data is contains 58,596 instances. So out of this, 29,000 is benign malware, benign, and 29% malicious. So this is
So
there are two
you
classes
have
only.
taken all columns,
Whether it is
56
malicious or
column?
benign.
You have taken all 56 column, or you have generated the correlations?
Sorry, sir, I didn't get you, sir.
You have used all 56 columns.
Yes, sir. We used all the 58,000 instances.
Then you not generate the correlations between the different features?
So in this paper, no, sir. Actually, we are not mentioning in that. So here, just we'll concentrated on just only for whether the systems contain malicious or benign names. Just only using some model. Just will concentrate on that classification things only, sir. We didn't get any relationship between.
Okay, but I think so you need to find out the correlations between the features, so that which features are more related with your malware or the particular research. So accordingly, we will apply the different type of the algorithms. Then you will find out some better algorithms. Then I hope it will little bit better.
Definitely, sir.
Okay.
So actually, this is our first paper. So definitely in upcoming days, definitely incorporate all these things and go ahead, sir.
Okay. Okay. Thank you.
Okay,
Yes.
sir. Thank you so much, sir.
Over to you, ma'am.
Thank you for your presentation.
Okay, ma'am.
We have come to the end. I sincerely thank our authors for their contribution to this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during this 8th version and previous 7 versions of the conference. We will be happy to have you in the 9th version in 2024. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2023. I also thank our session chair, Dr. Ramesh Chandra Punia, for chairing the session. A token of appreciation to the chair on behalf of the team ICTCS 2023 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. So, would you like to provide any reviews on this conference?
Yeah,
Sorry to
Thank you.
interrupt, sir,
Thank you.
and sorry to interrupt, ma'am.
Oh, thank you, ma'am. Thank you, sir. Thank you so much.
Can we have the picture, sir? Hello, ma'am.
Yes.
Can we have the photo, ma'am?
Yes, we are having. Everyone kindly turn on the camera so that we can take a quick snapshot. Thank you for your presence.
Thank you, ma'am.
Thank you, sir. Thank you once again.